All right. Uh, Thank you for coming here for the last presentation. It took us a while to configure all the stuff, so I'll try to be quick. So today I'll tell you about the field of AI security and adversarial machine learning, its history and current state. My name is Eugene, and I'm a CTO and co-founder of a company called Adversa AI. And before founding Adversa, I managed security research and development with the focus on transforming research into products. And I'm also a security researcher and author of the report that covers the past 10 years of adversarial machine learning. So I'm using this report today for my presentation, and if you want to dive deeper, feel free to download it with the special link I prepared for you. A bit about our company. So we are a startup with a mission to increase trust in AI systems by protecting them from cyber threats. And we are a team of hackers and researchers, and we work in 3 directions. So all of these things you can see on the slide are not products, but resources we have created, so you may find them useful. For instance, our AI risk advisory team has released a report on the adversarial machine learning. So we also have a practical course on attacking AI systems, and we also write a blog posts and newsletter with the reviews of research papers about vulnerabilities of neural networks. Our AI team conducts vulnerability research and speaks at conferences with the results of security findings, and you can explore our other presentations. And our AI security engineering explores ways to automate security testing and develop protections. And we have recently announced our attack engine for facial recognition systems, and also a sample lifecycle for secure AI systems. So why should you listen to this talk? First of all, my main goal for this presentation is to get you up to speed with the current state of machine learning security. I'll give you some historical context, but mostly focus on what is the state of the field today. So you clearly won't learn how to hack systems, but you'll know the field, the dependencies, what and where to look for. So I'll break down the main Ds into 3 sections, which is essentially a stages, like stages in a security lifecycle. When you decide to start something, when you decide to start AI security program, you start with the threat awareness. So you learn about realistic threats. Then with the risk assessment, you evaluate the real security posture. And finally, with the security assurance, you develop mitigations for what is discovered earlier. First of all, let me tell you a story. 5 years ago, I've been building a threat detection products, and it was 2016. I went to the RSA conference in San Francisco, and the main topic of the year was machine learning for cybersecurity. And I was like, okay, I need this stuff. We need to get our products to the next new level. So we decided to start implementing some ML for our threat detection tools. And it took us around a year to formulate the product tasks, collect some data, build efficient prototypes, and get ready for some real-world testing with the friendly customers. But the only problem was that it became fundamentally broken. And after some success, we have realized that all models could be easily fooled. So basically, the product became less secure with the machine learning than it was before. So we were quite surprised that we were able to bypass many types of threat detection models that we have built. I just want to give you a couple of examples. For instance, we have built an attack detection for web applications, basically some kind of smart firewall, which was based on machine learning. And we were able to bypass it just by changing some payload parameters or introducing new types of request encodings or just distraction features. So you can think of this as a traditional firewall detection bypass methods. plus some weights for these methods when ML is used. And another example, we've been building user behavior anomaly detection. And for this anomaly detection, we're able to generate some targeted events quite slowly. So when the system conducts some historical analysis, it would recalculate baselines for what is considered normal for this user. And that way, we're able to change our behavior and stay under the radar for anomaly detection and for threat correlation. So basically, this was the moment when I first got introduced to adversarial machine learning. And at the time, it was quite early years of this field. And we tried to fix all these things for a while, but by doing some like common sense stuff, like changing models or changing data sets, like introducing new features, augmenting data sets with some bypasses. But after some time, we have realized that machine learning is fundamentally vulnerable. So there is no such thing as a security patch as we have in traditional software. And basically, with that state of AI security, many security solutions that use neural networks could be considered useless unless they use it as one of detection engines, not the only one. So as I have mentioned, our product became less reliable after we added machine learning. And really, if we think about this approach more deeply, we can see that AI algorithms or machine learning models, they expand the attack surface. And systems based on machine learning are often called software 2.0, which kind of implies that there are some approaches and methods. And if we compare it to traditional software, we can see some obvious differences. Machine learning models are less deterministic, so the workflow is more dynamic and is based on learning. So essentially, the system behaves differently in different environments, even if the system was designed the same way, even if it's the same code. Some more advanced AI products, they also have some non-traditional interfaces like voice interfaces or text interfaces. And of course, the security problems could be different here. On the one hand, AI systems that use machine learning are just yet another example of software, and this is totally correct. That's why you can expect many smart pieces of software have all the traditional types of vulnerabilities and weaknesses, such as problems with the input validation, access control issues, misconfigurations, environment issues, and so on. But on the other hand, AI systems have some new types of behaviors. And as a valuable system, it's expected to have adversaries. And it would be an obvious target for attackers, but they would attack differently. So while the software environment of AI systems could have traditional security vulnerabilities, I want to focus on the extension of the attack surface and tell you about machine learning algorithms only. So these days, I can see how AI can be an attack target and attack vector at the same time. So it could be an attack vector when machine learning is used as a smart layer for software. For instance, attackers have some motivation to hack the product itself. They don't care about whether it uses ML or not. So ML is just an obstacle. So they could potentially exploit traditional vulnerabilities, but ML vulnerabilities offer them new opportunities to attack the system, and it might be easier to do than in a traditional than to exploit traditional security vulnerabilities. And in another case, ML code may be the core experience of the product. For instance, self-driving cars or AI coworkers, which is a fancy word, fancy saying for kind of smart business bots. or smart speakers such as Siri or Alexa, they wouldn't really exist without ML. So in these cases, attackers are more conscious about exploiting vulnerabilities of machine learning specifically, rather than in the previous case. So in this case, it would be a target. And now let me take a step back and show you that the security problem is not the only problem of AI systems. AI has enabled many new applications, and it's hard to deny that it's powering many applications in different industries, and it's been adopted quite rapidly. And together with AI features, companies introduce some new problems. There are different communities that work on problems of AI implementations. And traditionally, you would hear that algorithms may behave unpredictably or even be unsafe. They could not explain their decisions, or they often motivate companies to violate users' privacy for the sake of data collection. And some systems may discriminate people by various criteria such as race or gender. And each of these problems is a separate field of study. And collectively, they're called trusted AI or trustworthy AI or responsible AI. Unfortunately, there is no common definition, and these terms may be used interchangeably. And we didn't like this at Adversarial, and as technical people, we like seeing systems everywhere, so we have created our own structure that is easy to remember and easier to focus. If you use this as a playbook, then you probably have different teams focusing on different columns. So basically, all three areas are essential for the trustworthy AI. Reliable systems should work under normal conditions and behave predictably. They offer human oversight, so they're accountable, and humans have control on the decisions of the machines. And the decisions must also be explainable. In fact, in some industries and in some locations, like in the US and financial industry, it's illegal. It's illegal to use a system that can explain decisions if it's a financial system and it's making decisions about people's like loans and stuff. The next group is resilient systems. These systems should work under adversarial conditions. It may be environment changes or some people interaction that defines a safe system. So basically, security here is in the traditional meaning, in traditional cybersecurity meaning. This includes security of AI environments, infrastructure, and also adversarial machine learning, which is about neural network algorithm security. And privacy covers data protections and access controls for collected or inferred data. And finally, responsible systems are defined by their impact on people's lives. So they must be unbiased and inclusive. They rely on moral principles when they interact with humans and essentially make people's lives better. And all of these requirements are equally important to have a AI that we could trust. But today I only focus on the security part and the part related to adversarial machine learning. So when I talk to people, some of them tell me that it's too early for adversarial machine learning to become mainstream. And it might seem true to some extent because there are many unsolved problems in traditional cybersecurity, and or just managing machine learning models is a total mess today. So they have ML ops tools, but it's still in its infancy. So the modern tech world is overwhelming, and they don't have time, neither time nor knowledge to address these machine learning security issues. But this is exactly the reason why we have all these problems, because no one acted early on to build things right. And if we think about people who built computers like 50 years ago, they didn't design it with the security in mind. They just designed it to move the progress forward. And the same is happening with AI systems. So that's why it's really important to start securing AI systems early, because one day it might be too late. Now let's take a look at some progress of adversarial machine learning over the years. So the data I'm using today for my presentation is based on the archive.org website, the main platform for publishing non-peer-reviewed papers. And we have collected a comprehensive data set of what we believe is every paper that exists on the topic. And obviously, I cannot provide in a short presentation all the data that we have. So you're free to explore the original source, the report that we have published. And now I want to provide you some highlights. When we talk about this field, it seems quite new to many, but in fact, there are more than 2 decades of research on this topic, and what is traditionally accepted as the start of the field happened in early 2000s. At the time, they already had papers exploring how to bypass or protect spam applications, spam filtering or intrusion detection systems. And if we allow the topic to be more abstract, there are papers dating back to early 90s that explore machine learning under malicious noise. And for a long time, it remained a very small area of research. And later in 2014, the paper on adversarial examples for deep learning was published. Around the same time, we had explosion of other deep learning techniques, and from that moment starts the era of adversarial machine learning. Another milestone happened a few years ago. In 2011, 2019, we saw a growth of governmental initiatives, mostly government and military initiatives in the US, and the US defense grants and from DARPA agencies and from other intelligence communities motivated to start this research in many universities and corporations. And basically, if we take a look at the geography, we can see that the top 3 countries that contributed to the total body of knowledge are predictably the US, the China, and Germany and UK. Unfortunately, we don't have Hungary here, but if on this map you can see there are over 50 countries that published some research on this topic, but only 14 countries generated over 90% of all papers. So essentially, if you publish several papers, you would go to the top 20 or top maybe 15 or something. So it's very easy for you to do. If you're really interested, you can do this. And as I have mentioned, the initial growth is motivated by national initiatives and defense programs. And we cover more of this in our report with the timelines, which government was the first and who relied on what. So if you're interested in these details, you can also read our original report. So here I want to tell you about the 2 biggest drivers. They are predictably the US and Europe. As in many other fields, the US is driven by military, and Europe is driven by regulation. So all of these initiatives are very recent. In the late 2018 and early 2019, the US intelligence agencies proposed several programs for securing AI systems, and later on, other agencies and corporations, they also started their initiatives and started publishing papers. And many of them created joint research labs between a university and corporation. For instance, many top corporations like Intel, IBM, Amazon, Google, most of them have joint research centers with some universities focusing exclusively on securing AI systems. And that's why if we go back to the statistics per year, we can see that more than 90% of all papers are created after 2018. And from the 2019, European organizations started releasing important initiatives. And the latest one is a proposed regulation that covers high-risk AI systems, and it includes requirements for AI risk management, data governance, technical documentation, security monitoring, and so on. So as we just saw, governments and academia are serious about the security risks for AI systems. So let's see some industry initiatives. Basically, before the 2018, there were very few activities in the industry, and mostly independent researchers speaking at hacking conferences and trying to share knowledge or trying to convince business stakeholders. And later, around 2018, big consulting firms started offering services in the field of responsible AI. And later, a few startups appeared, just like our startup, adversarial. And from 2019, Gartner started covering the topic of AI governance and risk management. And around 3 weeks ago, they have released their very first market guide on this new emerging field. They call this market AI Tourism, which stands for AI Trust, Risk, and Security Management. So it's not just a research topic; it's the whole field. It's that consists of multiple professions. So it could be like a real career. And very lately, many AI teams appeared in big corporations that heavily rely on machine learning. So these companies are trying to prepare and to address real security risks for the AI systems, while also anticipating some compliance requirements. So as you can see, many things are happening. And here at Adversa, when we just started our company, we wanted to collect just information just to understand the market and trends and what is the current state of the art. But we were so overwhelmed by the amount of information, so we decided to probably we should organize it into a report and share with the community. So if you want to go deeper and learn about all these topics, you can download the report with this special link. And together with this presentation, I hope it may become a go-to resource for understanding the current state of AI security, or rather say AI insecurity. So after some introduction, let's dive deeper and see the attacks attacks against machine learning systems are not just an academic concept, but it's a real threat. First of all, I want to show you some statistics based on our dataset of all research papers, and then we will take a look at some real incidents. So overall, there are more than 2,000 successful attack cases against over 100 of unique AI applications. And we can see that all AI domains have been successfully attacked already. And if you see the distribution, it's quite curious how vision could be the most attacked domain. And I think there are a few reasons why computer vision has the largest share. First of all, is the most mature and popular application in deep learning. So that's why after its maturity, it attracts, after it goes to production, it attracts some interest to attack and protect it. It's also easier to demonstrate vulnerabilities with the images, because visual changes to images are more appealing. And due to the file structure of images, it's easier to create malicious images without changing the meaning of the image. If we compare it to changing binaries, they might become useless. So here you can see the top 10 attacked AI applications. These are just top 10, but actually there are over 100 of unique applications. And with the thousands of attack cases in the research literature, none of the tested models exhibited any inherent robustness and always failed against such attacks. So the dominance of attacks against AI systems with the image processing shouldn't make you think that other systems are less vulnerable. They just they just didn't attract enough attention. So I would say quite the opposite. AI applications with fewer attacks might be even at greater risk because the interest to develop defenses for them would be also smaller. And you can imagine that at least 90 applications have received more than 2% of attention, and even worse, the reasons why vulnerabilities exist are of the same nature. So most other applications that are not as tested yet could be considered vulnerable too, like by default. And after the initial analysis, I've grouped all attack cases by industries. So these groups are based on the purpose of attacked models and data sets. For instance, here you can see the column attack research, and it shows the interest of researchers to attack AI applications in a given industry. For instance, facial recognition would obviously go to biometrics, and attacks against semantic segmentation from the with the data sets from the self-driving car cameras would go to automotive industry. And it's also important to note that some applications are used across industries. For instance, image classification. If the generic model is used widely, but across industries, but in the research literature it's attacked in the healthcare case, it would be unfair to not count it in other industries if we want to calculate some real risks. So that's why we came up with the idea of transferable risk. It can show the real applicable risk based on our correlation. So we assume that attacks on similar AI models across industries are comparable. For instance, attacks on facial recognition systems are transferable between biometrics and surveillance. This way, biometrics attacks would be counted toward the surveillance industry and vice versa. And similarly, if object detection is vulnerable in self-driving cars, the same object detection models could be used in surveillance systems, so they are counted in both industries. And with such correlation, we can see that even researchers attack internet applications in only 23% of cases. Over 97% of attack cases are applicable to AI applications used in internet companies. So we can see that attacks are transferable not only across models, but also across industries. Now let's take a look at the attacks in more details. I believe everyone knows the CIA triad, which stands for confidentiality, integrity, and availability. So they describe fundamental requirements for any system to be secure, and the same we might have for ML models. But sometimes the same attacks may touch both confidentiality or integrity and availability. So we decided to reclassify all the attacks based on the impact on the victim systems. For instance, here we have grouped all existing attacks into manipulation, infection, and exfiltration groups. Manipulation allows attackers to bypass expected AI behaviors and make AI systems perform some unexpected jobs. and attackers could craft some malicious inputs and conduct evasion attacks, basically fool the system with the different threat scenarios, for instance, to disappear from the detection or to appear as something else, like as a different person, or just reduce the increase the misclassification error. Or adversarial reprogramming attacks may just make the system conduct the task that it wasn't trained to do. Infection attacks reduce the quality of AI decisions and enable stealth control of AI systems. There is a family of attacks, of poisoning attacks, and attackers can contaminate data used for training to reduce the quality of the decisions. They can exploit hidden AI backdoors or distribute malicious AI trojans and control behaviors of AI systems. This is a real risk, considering how many AI models are downloaded and used as is, rather than developed internally every time. And exfiltration attacks aims to steal data from AI systems. Attackers can extract data used for model training. They can get private inputs. They can steal details of the model and basically clone the model. And imagine that in a big company you may have a team of like 10 or even more engineers, and you can imagine like the salaries in the US, and then you, with the few $100 you can steal all the IP they have generated and clone the model like in a few days. So yeah, after analyzing all papers, we have created a top 10 of all the attack methods against machine learning algorithms. So here you can see them on the list. I will not go into details about each of these attacks. You can learn about them from many good presentations, and we also have a course on this. And each of these attacks would require a separate presentation. So I just want to highlight an important issue here. As you can see, all of these attacks are quite serious in terms of impact, but the interest in studying specific attacks is not evenly distributed. For instance, the first place evasion attacks have only 80% share, but the 10th place has only 0.2 share of interest. So basically all the attacks starting from the third place are lower than 3%. With the thousands of papers, you can see how not enough attention is paid to very important and very risky stuff. And this might be a problem because low interest in researching attacks translates to low interest in developing protections for AI systems. And apart from the top 10 systems, I wanted to highlight some other interesting attacks against AI systems that didn't make it into the top 10. In fact, there are many papers that I have only 1 or 2 papers on the topic, so it's not enough data to classify them as something. So together, collectively, I call them kind of AI environment attacks. And there are very few papers that are kind of extremely useful outside of these traditional adversarial machine learning papers. But what could be interesting is that we've all seen kind of advanced uses of deepfake generation with the help of GANs, and that's the engine that could be used to generate attacks. So the GANs could generate adversarial examples for evasion attacks. Another example is basically the usage of neural networks for steganography, and real malware files can be hidden inside machine learning models that is used as a medium. and there are real prototypes for this. And the last case essentially is a denial of service attack that increases energy consumption. And basically it's a slowdown attack that makes AI models unresponsive. Some other types might be quite familiar for people from the traditional cybersecurity field. These attacks include exploitation of vulnerabilities in third-party libraries or machine learning frameworks may have their own vulnerabilities. And there's a growing number of side channel and fault injection attacks. So some of these attacks from research papers may look too futuristic or not relevant for day-to-day operation of AI companies. And my main point here is that attacks against AI systems are not just an academic concept. I want to show you that there are real attacks, and they're more real than you might think. So first of all, I'll start with something simple, and research papers are often criticized for attacking kind of sample or toy examples like image classification for data sets like MNIST or CFAR, that is essentially basic objects or handwritten digits. However, they also do a lot of real world testing. For instance, many companies which you can think of when we talk about using AI in production in big corporations, they all have been attacked already in research settings. Here we combine together cases from academic researchers attacking some real products, and also corporate AI teams attacking their own products. For instance, in academia, there are security attacks that include fooling API-based models for well-known cloud companies. Like if you think of big 4 or 5 internet companies, each of them has been attacked already, and many of them have AI pentest teams internally. Another traditional case for such pentest scenarios is fooling content moderation in big internet companies. And the most favorite topic of the media is attacks against Tesla. And clearly, these are not like research concepts. Of course, we don't see some adversaries on the street, but the product, the Tesla, the car is real, and it can be easily attacked, which is demonstrated on many video recordings. And similar to academic researchers, internal AI pentest teams, they attack their own products in the controlled settings. And it's, of course, motivated by the demand to protect their systems. They already disclose that they see attacks in production against the AI systems. And from my own perception, the earliest works in internal AI teams started a few years ago in the companies that work in adversarial environments, such as cybersecurity, obviously, anti-fraud, biometrics. And there are research papers from these companies. They also have blog posts about it, or they say that they have protections against AI attacks in their product documentation. So this is real. And the second group is internet companies, which either have a huge audience and heavily rely on ML algorithms, or cloud companies that sell AI capabilities like AI as API. The next group of attacks is real attacks. So these are the things that we have seen in the wild. These are the real incidents where AI systems have been compromised, and such attacks, they don't require a threat actor to be conscious about adversarial machine learning. it still counts as an attack because it's the AI system that is being fooled with the malicious intent. And probably the most known of the earliest incidents that happened in the past years happened in 2016 when the Taybot, developed by Microsoft and released as a Twitter bot, was deliberately poisoned as a collective effort from some internet communities. And over time, we've seen a growing number of AI system failures against malicious actors. I believe that today, most of the spam filters are based on machine learning, and you certainly seen some spam recently. So they are frequently being bypassed. And internet companies, they constantly fight with abusers of copyright protection, content safety, recommendation systems. And another example is manipulation of various automated systems. My favorite example is when recently released report about Chinese hackers that fooled their national governmental facial recognition system for tax reporting. So they essentially create fake identities and fooled their advanced facial recognition systems to pretend to be another person, and they had some company, like fake companies, fake bank accounts, and they ran this operation for years. So probably we just don't hear about many attacks because there are no ways to detect such attacks against AI systems, because they from their traffic inspection, they look legit. It's the structure of the file, like if you send a picture to the API, is the structure of the file that is the carrier of the attack. And of course, AI is powered by data, and companies tend to accumulate a lot of critical information, and we'll certainly see a growing number of real traditional security incidents and data breaches. There are several incidents like this. If I'm not mistaken, the company in the UK, the healthcare company in the UK was compromised and data sets were stolen. And the recent case in South Korea, where not only the data sets used for AI training were stored, but also the company, it was the very first case in the world where AI company was fined under privacy regulations for disclosing this data sets used for the AI software. And now let me make a few predictions about the future of attacks. The first idea is that soon we'll see a growth of bug bounties for adversarial machine learning. We are all quite familiar with bug bounties in the security space. And besides being a useful source for crowdsourcing security expertise, they have created kind of a legal market for exploit sales, and they offer recognition and financial rewards over some shady black market experience. And there are signals such as academic competitions, contests from the defense organizations, and also vendor contests. For instance, last year, Facebook hosted a deepfake detection challenge. And recently, Microsoft has announced, this year, Microsoft has announced a malware evasion contest with the focus on fooling neural networks. And also recently, the Twitter has announced the bug bounty for ethical issues, mostly related to recommendations and some user experience and minority groups. So I think soon we'll see new types of bug bounty programs. So they could be like in Twitter case or Facebook case, they could be AI focused, or traditional security programs could extend their scope to include AI systems, or at least traditional like big tech companies with their bug bounties may include AI APIs as a scope for their bug bounties. And the second idea is that as bug bounties transfer from the security to AI world, many traditional attacks could be applied to AI systems. So when we secure AI systems, we not only care about adversarial machine learning, but also about all other things. And it's very clear how academics, they gradually take classic attacks and apply it to adversarial machine learning. And it will be very easy for real attackers to extend their scope of work. For instance, such things such as supply chain attacks happened already. This also includes fake open source packages that are confirmed real incidents. The poisoning attacks, they also happening already, not in ML space, but in other spaces. Like, for instance, cryptocurrency exchanges may lose a lot of money when their price feed is hacked, is replaced by malicious parties. And it's not difficult to imagine that many existing attack examples from non-AI space could easily transfer to AI space. So the number of incidents will only grow. And the last idea is that soon we'll see more documented incidents. One of the ideas that I have is that it's not possible. There are no products in production that could detect like firewalls, attacks against AI systems, and we just don't see many attacks. Another side of this coin is that even if the attacks are happening, they're not either disclosed or documented. Right now, there are a few public databases that already have cases from various organizations, and these bases are mostly filled with the data about discrimination incidents, privacy violations, unsafe behaviors. But soon, I believe that we'll see more examples of security incidents. So as we can see, the attacks are more real and companies are trying to prepare for this. They conduct threat modeling and penetration testing of their AI systems that are supposed to shape their detection and monitoring capabilities, as well as incident response plans. And for that, they use AI red teams. And from my view, there are three main groups of teams testing security of AI systems. The first group, I believe, is the largest one. I would call them opportunistic AI security teams. Many of them don't self-identify as AI red teams or AI pen test teams, but for the natural reasons, AI security risks are first noticed by security people. So they either saw that there is a new important AI system that is no one trying to protect for some reason, or they learned some new attacks from a security conference. So they see it and they're trying to do something useful as the extension of their traditional scope of work. And the second group is security teams specialized on AI systems. So usually machine learning is at the core of their products. And judging from the public activities, Microsoft and Facebook are the leaders in promoting these types of groups. I think Facebook was the first to introduce a specialized AI red team, and later other companies followed up. And the recent news shows that even Pentagon decided to create their own specialized AI red team for the needs of the Department of Defense. And the third group includes some consulting and audit firms offering services for trusted AI, and some pentesting companies, for instance, TrailBits, and startups such as adversarial. So these companies focus on creating or using exploits for neural networks, as a part of their scope of work. And if you're wondering what all these AI teams could be doing, I have prepared a list of cases that we have conducted in the recent time. So here at Adversarial, we do vulnerability research and consulting, and we're able to cover cyber and physical cases. As you can see, there are attacks against models, like when you work on the software level, you can attack devices as a black box target, and you can also work with the API services, AI as API cloud platforms. So as you can see, there is the real demand for secure AI systems from different industries and across the use cases. But what about security? As we can see, adversarial machine learning is not just a research topic. It introduces some real threats to AI systems. And what is here for defenders? To understand the current trends in the field, I've used my dataset from the archive.org as it could be a mirror of what is happening in the field. So here is the distribution of all adversarial papers across 4 categories. Let's take a look at the first 2, attacks and defenses. You can see almost equal number of papers, and it can remind a traditional like cat and mouse game, or I would say arms race between attackers and defenders. But there is just one exception. There are many efficient attacks and next to nothing efficient defenses. And the second pair of surveys and tools represents interest in operationalizing adversarial machine learning. Most survey papers, they contemplate how to do adversarial machine learning research. They compare various attack methods. Unfortunately, very few papers explore what to do with all those security vulnerabilities. Very few papers explore the metrics or iterations, so how to make this field actionable in production settings. And similarly, there are many various tools, and collectively they even cover all the data types that could be attacked. But these tools are focused on researchers, so they're used in research labs, but they're not usable in production settings. So as I have mentioned, today there are no efficient defenses, and that's why we don't have a special coverage of defenses here. As there are fundamental challenges to develop secure AI models, I want briefly talk about challenges in detecting attacks. So I believe as the adoption of AI grows, we'll have more real attacks, but many of them will not be visible. We didn't hear about many incidents, but obviously industries operating in adversarial environments, they have always been attacked and abused. And some of them used in some simple forms ML for a couple of decades. It's relevant for anti-fraud, biometrics, cybersecurity, internet companies. Often they're not interested in disclosing them when there is no regulation for them. And there are very few news about it, but it's very easy to believe, judging from the silence or proof point cases when like well-known security products were easily bypassed in the wild. And in another case, recently the security vendor Deep Instinct made a statement that they see growth of adversarial machine learning attacks against their products, and they added protections against such attacks. And even if they wanted to tell us about such attacks, reliable threat detection for adversarial machine learning doesn't exist. So it could be happening already at larger scale, like at internet scale. It's obvious for everyone that when the 0-day appears or 1-day appears, like there are scripts that are scanning the whole internet. The same could be happening for all the AI systems and APIs. but we just don't see it. And it would be very stupid for many APT actors not to take advantage of this state of insecurity of AI systems. And as we saw in the beginning, AI introduces some fundamentally new problems in the security. And traditional security products also cannot cover adversarial machine learning. For instance, web firewalls cannot detect adversarial examples, and anti-malware cannot detect poisoning or model trojans, and application security will not reveal weak decision boundaries of neural networks. And despite some historical track record, if compared to general cybersecurity, the adversarial machine learning will look quite young industry. Let's take a brief look before we finish at what tools are available in the field of for practitioners in this field. So I have defined three main groups of tools that are available today. The first is assessment tools that are used to generate adversarial examples for various data types and sometimes test it with some sample defenses. In this category, there are many tools that are born from a single research paper, but some others have gained more traction. For instance, in our AI team, we try to use such tools to, when possible, because they offer a useful repository of attacks, but often they're not usable at scale or when you require many customizations. That's why we also develop our own technologies for testing specific cases. For instance, recently we have released a tool called Adversarial Octopus that is able to hack facial recognition systems. Our case is not unusual. For instance, there is a tool called Adversarial Robustness Toolbox, or IRT, ART, and it was initially developed by IBM and donated to open source, and it was useful for research, but had many limitations. So Microsoft used it as a foundation, and on top of this, they have built their own tool called Counterfeit, which is like Metasploit for AI systems. So as you can see, there is a growing number of tools, and on top of these tools, some companies try to build some real production instruments. And the second group is benchmarking tools that usually include some sample attacks and defenses, and they offer features for comparing efficiency of multiple attacks against multiple models. So some of these are available online with public leaderboards. So researchers also try to get in those ratings. So this is mostly used by researchers to demonstrate some progress in their research. And the last small group is for interactive tools used for learning. So the first tool here is used for visualization of adversarial examples, and the second one is developed by NVIDIA as a CTF-like box. So it's a vulnerable application like damn vulnerable Linux or web application where you can try to hack an AI system. So overall, many of these tools are useful for researching vulnerabilities in a specific model, but certainly these tools are not ready to be used in production at large scale. And there are some startups that are trying to solve this, just like what we do here at Adversa. So finally, what to do with all these problems? When we talk about AI systems, just like other types of software, they have their own AI development life cycle. And this life cycle will definitely need to be secured as a secure development life cycle. So here at Adversa, we have adjusted a well-known NIST cybersecurity framework to AI systems. You can get more details about it, about the sample lifecycle from our report, which I've mentioned earlier. Just for the sake of time, I'll skip the description. I just want to drop a couple of ideas here. So first, there are no patches for adversarial attacks in a traditional sense. There's nothing to install, and after this, the model is fixed. The mitigation that works for one system may not work for another system. So while out-of-the-box defenses, they don't exist, it's still possible to create a unique defense for a clearly defined threat model for a single application. but most likely it will not transfer to another model. And the second idea is that securing AI systems is more about operations than just patching. You should find vulnerabilities, evaluate defenses, evaluate trade-offs between security and accuracy, protect supply chains of AI models and datasets, secure AI infrastructure, and adversarial machine learning is just a small part of this. So here at Verso, we explore such defenses and how security operations for ML should work. So if you're interested to collaborate as a researcher or industry partner, just let us know. These are unsolved problems in the field, so we're always happy to see new challenges. So to give you some idea what could be the operational steps in this life cycle for adversarial machine learning, we could apply some operational wisdom from the general cybersecurity domain to security of AI systems. And here provide a list of the most relevant and important documents that explain how to apply security principles to secure AI lifecycle. These documents cover many aspects of AI systems, from risk analysis and threat modeling to operational guidelines and incident response plans. Many of these documents are in the early versions, so but they must be useful already because security field has taught us many lessons already. All right, so we can see that adversarial machine learning is kind of a hidden threat, but it can bring a lot of chaos. And I believe that securing AI systems is one of the biggest challenges of the next decade in the cybersecurity field. After this presentation, I want you to remember a few main ideas. Today, there are no defenses for AI systems. So every AI system is vulnerable and it expands the attack surface. So there is definitely the need for secure AI systems. The next idea is not too early and it might be too late. So think about how to develop defenses faster, then AI adoption grows, so there are more and more vulnerable systems. And then attacks against AI systems are real. They are relevant for all applications and industries, and chances are we just don't see them yet. And finally, defenses are more operational than technical. So start building some external expertise and best practices sooner. So if you're thinking what you should do next, as a security practitioner or AI engineer, here's my suggestion. So you can learn what kind of AI systems are used in your organization and share potential AI threats with your colleagues. You can try to perform some basic AI security testing with the tools you can find online and show some real impact. This should be super easy to do because every AI system is waiting to be hacked. And hopefully this works out and you can iterate on this and try to build security into the AI development lifecycle. So this is it. This is the end of my presentation. I hope you find it useful. You can follow me on Twitter or LinkedIn. And if you're interested in any type of collaboration, just let us know. And you can find up-to-date materials for this talk via this link. Thank you.